Hi, everyone. I go by Sangha. I lead an AI ML team at Adobe, and we are building multi agent systems for our customers. And I work in the space of B2B marketing. So we're building these things for marketers. Before working at Adobe, I've worked in education. And before that, I've dealt a little bit in healthcare as well. So as I go through the slides, I'll probably go back and forth between examples and all the domains I've worked in. A lot of the things I will talk about might be repetitions of what you've heard before, because I guess every day, the whole day, people have been talking about agents. But I'll try to see which slides have more value and spend more time in them. Oh, I need to be close to it. Okay, never mind. So before I start with the entire architecture of a multi-agent system, why do we even care about agents, right? And specifically for marketing. So I wanted to give one example. There are like multiple examples. And this is an example where marketers want to send emails to several tens of thousands of leads about their product. And they want to send the email in a way such that the people actually open the emails, read the content, and it should be personalized. It should be people who are only interested in certain products should get the emails about those products so that it's interesting to them. Now, in order to do that, traditionally, what marketers did was they went into this app. It's a product that we have, and there is tons and tons of configurations. So there's configurations where you set a character limit on the subject line. There's configurations where you set what the email template should be. The email body itself has 10 or 15 configurations. And you want to stay within these configurations because this is like how the marketing practice works. So you don't want it to be like completely free and open because this is a constrained space. And then once you've had this configurations, you also want to go and do things like A/B testing or rollouts to different types of customer segments. And even for this, there's another set of configurations. And finally, like all of this data, like whether someone opened an email or not, or someone listened to a webinar or not, needs to flow into the salespeople so that they know who are the people who are primed and they can go and sell their data. So there's another set of configurations again to make sure that the data flows in the right place. So what an agent does is it actually does all of this for you in an automated way. But now this is a part where the previous talk becomes really important is just because the agent can set the configurations and send email to 50,000 people, should it do it? And the answer is definitely no. You use past behavior of the individual marketer, of the marketer for that particular, for marketers for that particular company, and you make a suggestion for what these settings should be, what the configuration should be, but you still get a human review by the marketer. And at least at this point, it's really important because you're sending 50,000 emails. Now, this is not a credit card transaction or it's not a medical thing that it's going to really cause a huge havoc. But at the same time, you don't want your brand to not work. An example could be for some reason, the configuration was set that you're sending these emails to unsubscribed people. And that's a bad example, right? Maybe the agent did something and incorrect and got there. So it's important to have the human review in the process, but it still saves hours of going into a website and clicking on different things and setting these configurations yourself. And it's also something that improves as users keep using it and giving feedback on how these configurations are being done by the agents. And this is a particular example. There are like different directions in which the agents are being used in marketing. And that's why we need a multi-agent system as opposed to a single agent that's running campaigns. So next, I want to go into the agent orchestrator and specialized agent architecture. So this is the architecture we follow for the multi-agent system. So if you have a multi-agent system, you need an orchestrator. You need someone to say which prompt, which request from the user goes to which agent. You also need this orchestrator to plan out if you're asking for something like create a workflow for me, there needs to be a plan. Workflow does not arise out of vacuum. There are different steps of the plan. You show that plan to the user. They can approve of the plan. And this flow is similar to how if you're using Cloud Code or Cursor in the plan mode, they show all the plan and it could be step 2, I don't like it. I don't think I want to do this. You can again get the plan. And then the other thing that the agent orchestrator layer provides is a single SDK for all of the agents to be built. And the nice thing about this is that in that case, the individual agents that are being built don't have to worry about tracing or don't have to worry about a lot of the infrastructure. The infrastructure comes from the orchestrator. And very importantly, this also has a part that, okay, this doesn't work so well. Maybe I need to be closer. But from here, I can't see. So very importantly, like the last part, which is tracing, every part of the conversation is traced. And those traces are analyzed constantly. And I'll talk about evaluations and other things. And that becomes a feedback loop into improving both the orchestrator and the individual agents. I've put in some specialized agents. We have a suite of many more. I've put in the work ones that I'm more closely connected to. So we have an agent that lets you discover your data. This is more you're retrieving data from the databases. So it tells you about which leads are interested in which products, or so it gives you the interest of the people that you may be wanting to send an email to. It tells you about, you can ask different types of questions, but it tells you about their geography, like where do they live, or what kind of job title do they have, or things like that. So it basically gives you a lot of information about the leads. And sometimes the marketers want that. They want to discover what's in their data. At other times, they might want a structured plan, and that might also come up. And that also comes partly from discovery, but then the structured plan would also have, after the discovery, typically you have a list and you want to create a workflow for that list. The other agents that are here are like a question answering agent, which is mainly a knowledge agent kind of a thing, which answers questions from documentation. It uses RAG and vector databases and so on and so forth. I think I have a more detailed slide on this. And going ahead, other agents are like wanting to create customer support tickets because some things are not working. So customer support ticket, you might be using your regular web page and creating those 100 configurations because you're used to it. And then the customer support agent would come up, and if something is not working, you can have a session and create the customer support tickets. And campaign, I've been talking about the campaign agent as well. It will just set configurations and show them to you. What's interesting, some of the things that are interesting here are like the workflow agent essentially creates a graph. And within your workflow agent, you need to make sure that the graph is valid. And if you don't do that, and it can be invalid because your LLM is creating the graph on the fly, and sometimes LLMs hallucinate. So internally, you need to have mechanisms to check, is this graph valid? Now, if your graph is invalid, what will happen is once you create the workflow, it'll plug into somewhere real and actually create a workflow where different nodes in the workflow are doing different things. And that API call or that tool call will fail and your whole system would break. So these are like some checks and balances you need to develop within each of the agents. Going further, the next thing I really want to talk about is closing the demo to production gap. So when you're doing a demo, you have the agent orchestrator, you have a pre-configured prompt that you have tested a lot. It goes to the right agent, you get the right answer, and it all looks very good. But then when you let it out in the real world, humans are fairly creative with language, and they can ask the same thing in so many different ways that hallucinations are quite common. Going to the wrong agent is also common because you might be having two agents that are retrieving data, but they're retrieving data on completely different things. So it's important to control for these. So how do we do that? There's something to think about where things go wrong is agent selection, context preservation. So when you're in workflow agent, very often you will need some information from the agent before to create that graph. And if you don't maintain that context, then you're going to, or if you there's one part maintaining that context. There's another part if you send too much information from that agent, you could also create a graph that makes no sense. So you need to focus the context as well. For creating the graph, I just need these three pieces of data. Make sure only those three pieces of data go through. Tool access agents can share different kinds of tools, and you could easily call the wrong tool, have a perfectly valid answer, but the wrong answer to whatever the question is. And then observability is tracing end to end. One good way of thinking about this is not all parts of the agent are conversational, but a lot of this data is free form. So keep your data in a NoSQL database, Mongo, DynamoDB, something like that. And then you want to build metrics on top of that data. So build metrics on top of the data and put it in a SQL kind of database, and then you can connect that to a dashboard and you can see how all your metrics are performing. So that's where the observability really comes in. What else is here? Okay, yeah, the golden data set, that's a very important point. As you're building the agent, I think someone else also mentioned this, that you should have an eval harness before you even let it out in the wild. So that's like the golden data set. That is the prompts, the multi-turn conversations. It could be something as simple as build a campaign for me. And maybe the person doesn't want to have a conversation. After that, he just wants to see what's the campaign itself. But have that golden data set. You have product managers, volunteer users, volunteer customers use the product and create it. And this golden data set is something that's alive. It's not fixed in time. So every 2 weeks, there should be bug bashes and human in the loop interactions. And this data set keeps increasing. And against this data set, you can constantly compute metrics and compute how your agent is doing. One way of doing this, it would be synthetic monitoring, where you send your golden data set, let's say every hour or every 15 minutes, depending on your use case, or twice a day. It really depends on your use case and how much tokens you're willing to spend. And you compute all the metrics that you get. Typically, your metrics, some of them will be very tool based, error handling, and all of that. Some of them will be like LLM as a judge, where you define metrics, give positive examples, negative examples, and then constantly monitor the metrics. If you get alerts, then you know something is wrong. You have to go back and check what's going on. You might need to switch an agent off, which is fine. The orchestrator would handle it and say this use case is not handled right now. So all of this needs to be there. Another very important point is agents are, as you have a multi-agent system, a lot things could go wrong in a lot of different ways. And you would think, okay, my orchestrator has 90% accuracy, my agent has 90% accuracy. So for everything, every use case, I should get about 80%, right? Because it multiplies. But it's not that simple. And it's not that simple because first you go to the discovery agent, you do something, you get some information, then you're supposed to send that information to the workflow agent. Maybe from the workflow agent, you send something else to the Q&A agent, and many other directions. Now, let's say if your data is not very well preserved in this part, then even if your individual agents are working really well, there could be like your final agent might be performing at 40% because not all the correct data got transferred, or a lot more data got transferred than it should have been. The other agent went and looked at the wrong part of the data and created something that was not correct. So it's important to test end to end, and it's important to test the whole ecosystem and not just one agent. Now, I'm saying this particularly because sometimes different teams will build different agents. And there will be a period when they will be doing testing in a siloed fashion because they have to build their agent and they have to take their agent to 90%. But it needs to be planned out that at time X, we are going to measure the entire system as opposed to just a single agent. Another thing to really think about, and it was there in the previous slide, is the way Agent Orchestrator works is that it looks at the agent card of each of the agents, which basically gives you skills of the agent. It also gives example prompts and decides whether to send this prompt to that agent. So that agent card constantly needs to be updated. Typically, what happens is you start with an agent, then you get more product requirements, and the skills of your agents increase. So there needs to be like an automated process, maybe like another, like a automated Claude agent, something that goes and checks against maybe weekly or maybe against some number of PRs that has a new skill been introduced. If a new skill has been introduced, then it can recommend update the agent card. Now, the agent card should not be updated automatically. It's a central part of the multi-agent system. It should be a PR, and then multiple people should review that PR, including PMs, because PMs very often define the skills of the agent. And then once there's enough review, the agent card update should be locked in. The next thing I want to talk about is we've been talking about agents so far. So we should get an agentic environment that helps us improve the agents themselves. And if you look at it, there are these two ideas that are floating around over the past few weeks, or maybe GEPA has been around for a while now. So the full form of GEPA is Generalized Pareto Surface. And what it does is it looks through the trace and it looks through all the logs, and then it analyzes using LLM's natural language that what improvements should be there. Once it analyzes, it suggests the improvements. It also suggests improvements in a way that multiple use cases can be improved. And that's like the Pareto surface. And you can combine, let's say you have one prompt and or one question from the user, and there is an improvement that's corresponding to that question. There is another question, and there's an improvement compared for that question. The first one may be a simple one. The second one may be a complex SQL join or something like this. But using the GEPA framework, you combine both of those and you make the improvement. And this is something you optimize for during the day. So it's not something that happens while you're sleeping. It's recommendations that you get. You get the traces for all of the recommendations. You choose the best recommendations you want. AutoResearch, which has been making rounds for the past few weeks, I think. The original post by Karpathy was for building an machine learning model, and it had these three files: the .md file, the train.py, and the prepare.py. And the idea there was your agent goes in, there's a model, it modifies the parameters, runs an experiment, and gives the result for that experiment, and constantly keeps doing it throughout the night while you're asleep. And anything that leads to improvement is pushed into Git. Anything that does not lead to improvement is reverted. And when you wake up in the morning, you see all of this and you decide what to keep and what not to. In the agentic world, it is a little bit different. So for this to work, as a human, you really have to know what are the metrics, what to put in the MD file, which is true for all auto research projects. But you need quite a bit of human expertise here to define that you're going to improve against this metric. This is the golden data set. So if you don't have them very fixed, this is a little harder to do. You can still do it, but you might want more manual intervention in the results to decide whether you want to keep it or not. But these are some ways your agents can improve themselves, and you can get to higher accuracy in the metrics that you're choosing. Of course, choosing the metrics is it's not such an easy process. Even with the LLM as a judge, the metrics that you choose need to be highly correlated to positive results. That is, when your PMs are using a system, the ones that they are giving a feedback as this is a successful one, whereas this is an unsuccessful one, you need to go back and define your metrics such that the successful ones, when they say something successful, the metrics should go high corresponding to those data sets. And when they say something is unsuccessful, it should go low. And sometimes the metrics do not behave that way. Doing audits on metrics is really important. The next thing that I want to talk about is data. So you have Claude, you have OpenAI, you have Gemini, Qwen, DeepSeek, like all of these models. And in principle, your user can directly go to these models and get what they want with some innovative prompting. So why should they come to you? So that your differentiator is your user data. So we have this behavioral data on people who are interested in these products. We have different kinds of metadata. We have other activities that these users are doing. So from all of this data, there's a lot of conclusions that are happening. And in the past, this data was used for predicting churn, recommendation system, and all of that. And we should still be doing those models, by the way, and saving that information in your databases so that the agents get access to them. But this data is your differentiating factor. Most of the time, frontier models do not have this kind of detailed data on a particular domain. So use that data, and then your customer experience will not be generic. It would be personalized. You would know things about them that other providers won't. And this is where it makes a real difference. And of course, as the agent is grounded in data, it generates new user activity. This new user activity enriches the ML models that you're building. You enrich your database with all that information, and then the agent can work on it. So now that I'm talking about data, I will go into a little bit to the next step. And does it make sense to build small models and use them instead of the large language models? So when you're building very fast, it does not. You use the external API, do your classification, do your NER, do all other kinds of predictions that you want with the frontier models. But then once you've done those use cases, you know that for some cases, it's very easy to build a distilled ML model. And for classification, for instance, you could use DistillBERT or Roberta, get all your training data from the large language model and build a small model that could take less than 100 milliseconds and not use your tokens to do like all of the work that was required. And that's the easy path. You can do this in a week once you have an established product where certain LLM calls really work well and all it needs is classification. You don't need to wait for 5 seconds for that result. You don't need to spend that many tokens. That's the easy path. The slightly harder path is fine-tune a reasoning model on your data. And here there are different ways of doing it. There could be like domain-specific data. You pick Mistral or Llama, some model, and train it on the domain-specific data. You also take your structured data. So I've been talking about structured data leads interested in these products or they live somewhere, maybe they belong to this demography and all of that. So you can convert that into English language and train your model. So now this model becomes very domain specific and can answer questions in natural language really well. Now, if you're trying to get data from the database, retrieval might still be more accurate, but that's something you have to test, whether it makes more sense to retrieve or get the answer from the small language model. So this is more like in the research phase, I would say, and something like you test out and figure out what's the best solution for you. Sometimes your large language model might still do better than the small model you've trained because you might not have enough data, or this model is large and it has the world knowledge like the GPT-5s that are coming out. So here there is a trade-off. Sometimes your use case also might not be very difficult and the small language model might be enough. The next thing I wanted to talk about is structured plans versus free-form discovery. So if you're using Cursor, Claude, like you have actually looked at this, you can go in the plan mode and get all the steps, interact, change the steps, or you could go into the not the plan mode and do a regular work. Now, which works at what point? So sometimes, let's say I want to build a campaign. I have built campaigns before, and I have maybe used the system to build campaigns before. So I really know what I want, and at this point, the agent also probably knows what I want. So in this case, showing a plan of how to build a campaign and just getting approval might be the best thing to do. And I'm not looking for too much creativity there. I just want to do my job and get done. But in other cases, let's say I'm a junior marketer and I haven't built a lot of campaigns. Now, this structured plan could still help to give some view into what a campaign looks like, but may want to discover the data. May want to say, okay, what are the configurations? What are the things I can change? What are my levels of freedom, or what is there in the data I want to see? Which companies the leads belong to that are interested in this product? And I'm just curious. At that point, the discovery mode works really well, and that's when you open up the discovery mode. In a lot of cases, people might start with discovery because of curiosity, because they haven't used the product before, and then they might eventually go into the plan mode because that's becomes their everyday thing, and then so you use the plan and you go ahead. The next thing I want to talk about, this is really important. It's memory. So a good way of understanding this is, let's say in the marketing context, I ask this question to the agent, run the same QA check on our EMEA programs. Here, E stands for Europe, A for America, I forget the rest. And they're just doing some kind of QAing here. So the agent doesn't know what the user is talking about. So the agent says, which QA check, which programs, what workspace. So even though this person has done this several times, they're like really getting at a point where this is very annoying. I've done it, you should know it, and you don't. So that's where memory kicks in. Memory can be at session level, where you're in a particular session and you basically store everything that's happening in a session. Of course, the context that's sent to an LLM needs to be either compacted or the last few turns, but the memory is still stored in some way so that it can get used. It can be at user level. This is where I would say the case where it was learning from the past campaigns and suggesting campaigns. This is where personalized user level memory comes in. And then org level. And org level is the system is being used by an organization. And this organization wants to say that I always say when I use Acrobat, I always say Adobe Acrobat. I cannot say Acrobat. So these are like org level rules that admins can set. And this is also part of memory. And an interesting thing about memory is that it's something that's alive, so it's not set in stone. And it's very different from the data pipelines or ML models that are writing data into databases. Here, there's an idea of retrieving the memory, there's an idea of updating and deleting memory, there's an idea of generating memory, and then if the memory is really old, it's pruned out. One way to think about it is, let's say I come in to my agent and I say, my grandmother Brenda baked a really good chocolate cake for me. And then I somehow go out and I come back and say, oh, that was not my grandmother. Actually, it was my aunt. Brenda is my aunt. And the chocolate cake was okay. I was just being polite. It was not that good. So now the memory would go back and take the relationship from grandmother to aunt. So it would update it and delete the grandmother relationship. It would also say the quality of chocolate cake. Let's say it was recording that. It goes from good to medium. So this is how memory stays, updates, and stays alive. It is similar to recommendation system, but it is different also in a way that it's not in the deterministic form where for recommendation, you pull data and show the recommendations. And MCP protocol, I feel like you probably have heard a lot about MCP today, but this is a great way of integrating tools into your agent. So in 2020, end of 2023, I was working in the education domain and we were building agents, conversational agents for students. And MCP did not exist there. I had teams across India who were building different tools for this agent. And for every team that was building the agent, I remember that there was one agent or two agents and five tools with every team. You needed a constant integration protocol and what is the security here? What is the integration load here? And how to, if it changes, what is the way to communicate that change? MCP takes all of that away. It's like a wrapper on top of your API. It's not very difficult to build. It does not add latency at all. And it standardizes everything. So your agent can just connect to these APIs and look at the documentation for the MCP APIs, and that's it. And MCP has security baked in, so you can definitely allow certain things to happen and not allow certain things to happen. For instance, delete email, it should not happen. Send email to 50,000 users, it should not happen without user intervention. So that's really convenient and it's the gold standard in the industry right now. Next, I want to talk about security. So when we talk about safety and security, there are like two buckets. One is agent safety, and that kind of falls in the bucket of is my agent going and deleting all the emails because of it has misunderstood something, or is it hallucinating a tool and returning some data that doesn't exist? Or does it have bias and does the goals of the model and the human intent match? So here there is no malicious activity. It's just, is the agent safe? That's the question. And then the security part is there a malicious action? Is there prompt injection? Is someone from the outside using my agent as an insider that is using my agent and somehow siphoning all the data that's there in my database? So these are things we have to protect against. And is it exploiting the tools? Is it exploiting my API? Maybe it's running some kind of bot to get all of their legal documentation done using the API, using the agent that I have. So, how do we make sure that these things don't happen? The evaluation framework definitely is evaluation and monitoring definitely comes in, where you monitor every part of the trace, calculate different metrics, usage, and everything, and set alerts on every part. So if somebody is misusing the API, the alert should go up and that authentication should just block that user. There are other parts to it as well, bounded autonomy. So when you start with an agent, don't let the agent do everything. Just define that this agent can do discovery and then it sends the data out. That's it. And then slowly, as the skills improve, slowly add more things other than saying that you can do a lot of different things. What does that mean? It means you have very good guardrail code. If it's in the marketing domain, for instance, if you're asking a question about pizza, I'm not going to answer it. I'm going to say that this does not pertain to this domain. So even though it's not harmful, just keep it within the domain. And that really helps. And then I spoke about observability and then human in the loop. Make sure when you have plans that are doing different parts to get the human approval before you send emails out. Cross agent containment, I spoke about this a little bit as well. When an agent is sending data to another agent, make sure it only sends the data that's required by the other agent and don't send extra information because that way you're exposing the other agent to all of the malwares that might come to the first agent. And this security needs to be built into the second agent as well. The second agent should also check these are the only data that I'm receiving. If I'm receiving anything else, then I block it. The other thing, MCP, of course, helps in this space. And then continuous bug bashes with PMs and other humans. This is expensive, but this is absolutely required because this space is constantly evolving. And even though I've listed a few things here, a new way of breaking the agent will come up tomorrow. And keeping the human in the loop constantly is what will help us. The last thing I want to talk about is when you're building agent as like building a team, I'm constantly hiring. Hiring for agentic building is very complex. It's not software engineering because everything is undeterministic. It's not building machine learning models because a lot of the time you're actually doing software engineering and you're building systems. So people who thrive really well here are people who have interest in machine learning, interest in data, interest in observability, but they're also good software engineers. When you say that, you're saying you want a unicorn, right? You want a person to have all the qualities. Now, one good thing is with Cursor and Claude Code, if you don't know something, learning it is pretty fast. So that has really helped across the board. But the other part is also to have a diversity in your team. Some people can be machine learning engineers, other people can be good backend engineers, other good people could be good front end engineers. And in this world, you might be working in all of these places. But if you have one specialty, and if you have other team members with the other specialties, you can easily collaborate and learn. You can collaborate with Cloud Code and learn. This is where I will leave things. These are the things I spoke about. That's it.